Hello, everyone, and welcome to our webinar today with the Red 5 Pro team. My name is Darian. I am a solutions engineer here at DigitalOcean. I've been here for about 6 years now, and joining me today are three members of the Red 5 team. We've got Chris, the founder and CEO, Mark, who is the CTO at Red 5, and then Monica, who is our developer evangelist over at Red 5. Welcome. It's great to have you all here.
Thanks, Darian.
Thanks for having us.
Thank you.
So one of the things, obviously, we wanted to talk about today is the broad topic is Red 5 and video streaming and how Red 5 does what it does. So I'm curious if you could lead into what is it that Red 5 does? What is it your team is known for?
Yeah, so we're principally a developer platform for allowing people to build live real-time video experiences, and usually that involves some level of interactivity with the live stream because that's where you care about the latency being as low as possible. And then the thing that really makes us unique is that we scale on top of cloud platforms, and you can deploy our system on any cloud. And we highly recommend DigitalOcean, of course, as one of those platforms to do so.
We appreciate that.
Yeah, and it's a fully programmable platform. Like every aspect of it is programmable. So you can intercept the streams on the server side, write your own logic to like feed it into AI, or you could write your own application logic to whenever somebody comes in and streams, then you can call like a backend service. All of those things are programmable, as opposed to some of our competitors are really focused on API only kind of driven systems. So you get a lot of flexibility with our platform, and you can build just about anything you can imagine. And for example, we're using StreamYard to do this like live broadcast right now. You could build your own StreamYard pretty quickly using our platform and deploy it on DigitalOcean. And actually, we're going to show a little demo of kind of a watch party type of experience that we'll get into a little bit later to kind of showcase a little bit of like what's possible.
Yeah, absolutely. And I'm curious, streaming is one of those things that obviously is becoming more and more popular. Everybody is getting into streaming. What makes it such a challenge in general to stream video and to broadcast it and to keep it low latency? What are the primary challenges you and Red 5 see with that?
Yeah, so one of the biggest things is scaling live video and keeping the latency down. Like it's pretty easy to do one of those, right? Like scaling live video and keeping it like a high latency, multiple seconds. You can just use standard CDNs and deploy your application out, and then you can get that happening pretty quickly. And then likewise, you can build video chat kind of applications where the latency is really low. It's like video chat latency. Obviously, the latency needs to be low enough to be able to communicate like that. Yeah. But then to get both to work together is quite complex. And so what we've done is created a whole kind of ecosystem for scaling WebRTC streams in particular, and getting one-to-many, many-to-many kind of scenarios. And the way we do that is through cloud VMs. Actually, if you don't mind, let me share my screen. I can actually kind of walk you guys through.
Absolutely. Let's take a look.
All right. Cool. So if anybody's looked into WebRTC at all, they've probably heard this myth that it doesn't scale. And that's actually true if you kind of look through it through the conventional peer-to-peer intention of the protocol. It was originally designed as a, point-to-point kind of communication for like basically video communication, like what we're doing right now with this kind of video chat thing. In fact, StreamYard is built on WebRTC if we're doing that kind of level of interactivity. But what we did is actually taken a different model, and it's what we call XDN, or Experience Delivery Network. It's kind of a play off of CDN. And we use VMs to handle the publish streams coming into origin nodes, and then edges receive or are responsible for distributing out to the subscribers of the video stream. So the flow of video always goes like this through our cluster. And on DigitalOcean, these would just be droplets when you deploy on DO. And this is a very simple cluster. And then we can fan out with relays. This is how we can get millions of concurrent viewers, because each origin would only have a certain number of connections being able to go out. When we stick a relay in the middle, we get exponentially more connections than what you can do that way. And then the cool thing about this is all these nodes can be deployed in multiple regions around the world and kind of get the edge nodes closer to people. And then the stream manager is the brains of the operations. It's usually behind a load balancer. It shares a common data store, and then it got its own API. So when you want to broadcast, you make a request to the stream manager, get assigned an origin, and then you broadcast direct to that origin. It gets propagated throughout the cluster, and then somebody wants to subscribe to that stream. They can make a REST API call again to the stream manager. You get assigned an edge, and you connect up to that stream, and then the video starts flowing down to that client. So that's kind of the ups and downs of it. And then we use the cloud network to spin up and spin down instances as needed. So if it detects a load in the live stream event and we need to add another droplet to this, we can actually, the stream manager technically calls Terraform, and then it will spin up an instance for you and add it to the cluster. And then when that event is kind of over and it's going back to its original state, it can actually tear down that instance. And so the stream manager is basically managing all of these aspects of it. I'm not going to get into all the CORS issues and all kinds of other crazy stuff that goes into this. I just wanted to keep it super high level, but anybody has any questions on this, I can definitely answer those questions, hopefully. And we have lots of documents on our site on those too. So.
Yeah, and I was going to say, all the folks tuning in, thanks so much for being here. We really appreciate it. If you have any questions, feel free to put them in the chat. We can see the chat, and we will, when we have time, stop and answer any questions that we have. We don't have any questions other than the prerequisite questions so far, so we'll keep moving for now. But this is really interesting, Chris. And Red 5 handles all aspects of this, or are there aspects that need to be handled by the end user?
Well, I think in terms of the video streaming infrastructure, we handle all of it. And now the end user, being the developer, has full control over this stack too, because they'd be deploying it on their own DigitalOcean account. And, they can manipulate it how they see fit. This scaling mechanism, we even have an event scheduling API, so you can schedule into the future when you might have an event where you actually have to scale out for that. All of this stuff is handled through the Stream Manager API. And then there are SDKs for iOS and Android and HTML5. We're working on a Unity and Unreal Engine plugin, as well as Mac and Windows and Linux SDKs too. So you can basically take any of these things, hook it up to Red 5 running in a cloud, and then you can build whatever you can imagine.
Now, does the auto scaling function exclusively on sort of machine metrics like CPU usage and memory, or is it also looking at stream metrics like number of visitors and activity in the chat or bandwidth or whatever the other considerations are?
It's based on number of streams, so you can configure these out to handle a certain amount of load. And usually the strategy is you want to have one of these edges configured to about half capacity, so that as it starts spinning up new instances to add to the cluster, you still have capacity while that's actually happening. So there's all kinds of strategies to handling that. But yeah, currently it's based on number of connections.
And this is just to bring in a question from the chat we just got. Is there an optimal size of droplet for the specific boxes that you're working with, or does it vary based on the use case?
It does vary a little bit based on the use case. We tend to use the what do you call it, the CPU optimized instances, and you can scale out using the C2 one, which is the the basic one, and that tends to work really well for handling the loads. We actually publish our load capacity numbers on our website, and then we run tests on those all the time with DigitalOcean droplets, and then of course we test on AWS instances as well, so you can kind of see. On AWS, it's like a C5.large is usually what we'll target for these nodes.
Mm-hmm. And then is there what operating system do y'all prefer? Is there a
Ubuntu? Yeah, Ubuntu 20. So
yeah, that makes sense. Absolutely. Thanks for that. And then we've got a more complex question from Dibiasom. I hope I'm pronouncing that correctly. Thanks so much for the question. If we want to add some kind of effect or ML Vision API to the stream, what's the best way to plug that in? Do we do the stream API, the client side, using some libraries? How does that work?
This is a great question. And the answer is it depends on what you want to do with it. You could certainly add that to the server side. And then if you did it there, what that ends up doing is making it so everybody sees the same thing back, right? And that can work well because then you're manipulating it in the cloud. You can also do client side. There's all kinds of ways to tap into doing effects. Like if you like, this is becoming kind of a standard feature for video chat. And then usually the best approach there is to do WebAssembly and try to do like C++ code on the client side to like wipe out the background and do other effects on it. So it really depends on what you're trying to do. If it's like license plate detection, let's say with like a surveillance app, you'd probably want to do that cloud based because probably the cameras coming in are probably from like RTSP cameras and you don't have much control over the client side code there. And then so you would be kind of forced to do it on the cloud instance. We do have a C++ API that we call brews, where you can write your own brew. And then that allows you to pull in the raw frames and then hand it off to something like OpenCV to do that work, and then push the frames back into the live stream going out. So I guess the answer is it depends on where what the application is specifically and what you need to do.
Yeah, so Dibyasom actually gave us a little clarification there. He said maybe collecting students' presence data for remote examination monitoring, right? So that's certainly a topic that's coming up to the forefront recently in the past couple of years. How do we look at, how do we monitor somebody who's in a video call from around the world, right? How do we understand what they're doing in that call? So that's a little bit of context maybe for what Dibyasom is looking to do there.
Yeah, I mean, in that case, either approach would actually work. If you did a client side, then you would have to probably like call that system from each client going out, and then you would have to deal with scaling it there. You could also do it server side. I think either approach would work.
Yeah,
I think a lot of it depends on your workflow too. Like, what do you want to do with that once something is detected? I guess if it's monitoring students taking tests, what you want to do is flag whenever somebody else is entering the picture, probably. Then it's probably an indication that somebody needs to look at that. Yeah, I mean, this could become a whole session unto itself.
Yeah, it's
how to build that
question.
application,
Yeah, absolutely. It's a great question. Thanks for that, Dibyasom. So that's certainly something, we may even talk more about this afterwards, but great questions. And then Chris Puel actually asked, can you integrate automated subtitles by default, right? So can you put subtitles in? Is that something that Red 5 provides, or is that something they need to write themselves?
You would have to integrate with another service that does that, like live transcription. But again, you have access to the raw audio frame, so you can push that out and then have a third-party service that does the transcription and then pipe that back in. You might have some tricky latency problems with that. I mean, live transcriptions in general are kind of flaky as far as I've seen, but I think it's getting better and better. I know Google has a really good service for this, and you could probably pipe into that pretty easily. We have one customer called Chorus AI. They basically do like meeting notes, live meeting notes. And the way we're approaching it with them is actually ripping the stuff to WAV files so that then they can handle it in the live stream to pull out. But I think they mostly are concerned with like historic stuff, like after the event is done, like the meeting is done. But you can do it live. I mean, it would be trickier, but you could definitely get it done.
Yeah, that's another big business that's growing right now is live transcription, right? Taking meeting notes for you. We've all had to deal with going back and forth between typing a bunch of notes somewhere and then actually looking at the conversation. It's nice to have it written down for you. But those are all great questions. Keep them coming, folks. As you can see, we got some real experts on the call here today, so take advantage of that. Squeeze them for all the knowledge they're worth. But thanks so much. Is there any other architecture stuff you wanted to talk about, Chris?
I mean, just other than like, this is kind of the basics. We also have built out we have ability to transcode the streams into multiple variants for like ABR support. So Cauldron is our like media engine, and we have a transcoder node in architecture. We do round trip authentication, so you can authenticate each of the streams, and this calls back to your business application server. So there's like all kinds of flexibility with what you can do. And then one of the things that just came out with the latest release is this mixer node. And basically what that means is you can take any web page and turn that into an output for WebRTC distribution. So this is actually, if you were going to go and build your own StreamYard, I would probably start with a mixer node in the architecture to basically create that output to go to RTMP to whatever you want. And then the other cool thing about this is you can also daisy chain these. Like you could say, let's say this first mixer is going to mix 10 videos into it. And then each of these are mixing 10. And then that composite could go into another mixer. So you could get 10 by 10 to get 100 videos up on a single screen. So again, like a surveillance app or somebody trying to monitor, maybe that's that great example of the student monitoring thing. You could actually have admins being able to watch a whole grid of all the students at once too. That could also be done with this kind of new mixer node. So this is a new feature that a lot of groups are playing with right now and doing really cool stuff with it. Yeah,
that is pretty neat.
I could keep going down tangents if we wanted to. I think
I'm sure you could. Yeah, but that one gives me the idea of the whole big wall with a million videos on it. Absolutely.
So we have a group called Stage Connects doing that right now with live concerts and presentations and stuff, and allowing grids of fans into the space so that then the musicians or whoever's performing is actually able to interact with those people.
Yeah.
And then they can actually call them up on the grid and then have a live video chat with that person too, which is pretty cool. So
that is pretty cool. Yeah. Well, speaking of building your own, which we've talked about a couple of times here, we talked about building your own watch party, right? So I guess I'd like to understand first kind of what defines a watch party when it comes to streaming, and then what does it look like if we were to get started building our own?
Yeah, I can take Darian.
Yeah, maybe we could switch to Monica's screen real quick. She's got the slides for this guy.
Great.
Yeah, so a pretty simple answer for what a virtual watch party is. It's a combination of video chat with a piece of content that you're watching. So in this case, we see our video chat here on the left with Monica, myself, and Chris, and we'd all be watching a sporting event, in this case, boxing. So, it's a way to get together and then consume the same content. You're all seeing it at the same time. That's hugely important for the watch party, so that, when something happens on screen, we all react to it together rather than, one person seeing it first. So the real question, though, is why the watch party? And that's on our next slide. So it's obviously a trend caused by COVID or accelerated by COVID that we're doing a lot more things remotely. And so hanging out with your friends or joining them to watch anything is now something that you can't do as easily as you did in the past. So you might want to choose to do it remotely. So at this watch party, you're going to interact in real time with content. So, both yourselves, the people at the watch party, and the content are live, and you interact with each other. Business use cases, we're seeing a lot of interest in live sports. So, we're talking boxing, mixed martial arts, horse racing. Of course, Super Bowl was just a couple days ago. Another great example for something you could do with your friends in a watch party. Also, live concerts, music events, those sorts of things. Live events like perhaps air shows or any kind of military shows would be a good for a watch party. And then you can start layering things on top of the watch party, like micro betting at the events. So you can imagine if we're watching boxing, we could choose who's going to have the most points at the end of the round, and bet on that, or we could bet on knockout in the next 10 seconds. Any kind of thing like that. And then also you can do things like shopping experiences where a group of people get together to actually look at a product they are considering to purchase. I think at this point, Monica is going to tell us a little bit about how we put this together.
Yeah. Yeah, and like Pace was saying, one of the big reasons to choose a watch party is because it's interactive, right? And it's interactive in a natural way. So, you want audio chat, video chat, both of which can be toggled on and off. And you want to be able to watch these programs and interact with each other at the same time without, having to turn to check the chat or, have FaceTime up on a different device or whatever it is. It's all right there. It's more natural. And it's perfect if you want to add any of those additional features that Pace was talking about. Works for a wide range of events. So how did we get started here? When we first looked at this idea, we split it into that video chat plus the main program that you're watching, right? So we realized that the watch party kind of combines a few features that Red 5 had already worked on. So the first was, a basic publish and subscribe to publish that mainstream and be able to watch it. And then that combines with our conference example, which is basically a video chat. It's multi-party communication. And we look to these as a base or a reference to get started. And then we kind of jumped in to building the actual watch party. So the first step here, we kind of started with the hard part, which is the video chat. And the basic idea behind it is to set up a publish stream and then a group of subscribe streams within the same session. So basically, you're publishing and you can also see everyone else who's in the room. To do that, you need a host. You need a place to go, right? So we used our conference example for a base here. In that example, you set up a Node.js-based WebSocket host, and that's where everyone connects to. So when you're joining the room, you enter in a room name, which is shared. Everyone uses the same room name. In our case, we called it just Red 5 Pro. And then you need a unique stream name. So in the watch party example, we have it automatically generate a stream name, but you can change it to anything as long as everybody's is unique. And once you enter those parameters, select your camera and microphone and click join, you're connecting to that host that you set up. So you're kind of entering the room, and that's when you begin publishing. So what's going on behind the scenes when you join? The watch party example makes use of something called shared objects. So there's a shared object that's accessible by everyone connected to that host, everyone in the room. And you can kind of think of it like a list of everybody who's present, I guess, in the room. So when you join and start publishing, that list is updated with your publish information. So then everyone says, oh, this person is here, and they can then see you. You kind of appear on their screen. Yep.
I apologize for interrupting. We're getting some feedback that you're a little muffled. I don't know if you can, if the mic is maybe close to your jacket or something. I apologize.
Sorry about that. Is this any better?
It is a little better, yes.
Okay. Sorry, old headphones. Should I start off from where I was? I can start over this slide.
Just starting at the beginning of this slide is totally fine, yeah.
Okay, perfect. Yeah, so when you're joining the room, what's going on behind the scenes is that we're using something called a shared object. So this is accessible to everyone who's connected to that host, so everybody in that room. So in a way, it's kind of like a list of everyone who is present in the room. And so when you join, you start publishing, and that list is updated with your information, your publish info. And since all participants are also connected to that list, they're able to then view your stream, and vice versa. You now have access to it, so you can view everybody else. That's kind of the behind the scenes. As a user, of course, when you click join, it just automatically subscribes to those other people who are in the room. And those are the people whose publish information is currently in the shared object. And likewise, when someone exits, that list is updated so that they're, removed from the screen. They kind of disappear as they exit the room. So that's the basic idea behind the video chat aspect of the watch party. The other half of it was just adding that main program, and this is the simpler part. It's basically that publish subscribe that we described earlier. So in our case, we publish an RTMP stream using OBS, so you can integrate third-party software. And then in the watch party, all we had to do was just add a subscribe function to connect to that specific stream. And we set this up so that the main program would autoplay when you join the room. And we'll get to see all this during the demo too. But once we had that added, that's kind of the basic functionality. So we worked on the layout and we kind of just had a very basic idea of what we wanted it to look like. A main program surrounded by viewers. We set it up with 8 fixed position participants. So, you know, when you join the room, you show up as viewer 1, as we have on this example, and everyone else kind of files in after you, filling up the bottom row and then the sides.
Yeah, so this looks familiar in terms of this layout. Certainly, the type of thing that I think we're familiar with, having worked in, you know, everyone working fully remote for the past couple of years, and so I'm curious. Dave had a great question. Thanks, by the way, for the feedback on the audio, Dave. Dave had a great question, which was, is there any facility for pay-per-view with a watch party like this? And I assume the question there is it possible to require somebody to pay to enter this watch party?
Yeah, so as you saw Chris present, there was a stream authenticator, and that's where you would hook up the stream authenticator to the backend services, which would be the payment services, to tell us that, you know, this user has paid. If they haven't, then it would redirect them to a payment process, and then when they came back in, we check again, they are paid, and we'd allow them to see the stream at that point. So relatively simple and very much a straightforward use of the stream authenticator module.
Yeah, maybe something we'll see happening more and more in the world. Would be certainly an interesting way to pay for your attendance to a concert or a basketball game. Mm-hmm. So Susan had a great question as well. This obviously shows 8 people. Is there an upper limit, sort of logically, in how many people we could fit on a single watch party like this? Obviously, you would need to scale out the resources, but is there a max? Is there some limit, or do we just use repeaters and it scales infinitely?
So this is a interesting question. Right now, yeah, 8 was totally arbitrary and just like picked for this demo. Plus, it also becomes a UX problem. Like, where do you put everybody when you start getting into crazy numbers? But the way we're going about it right now is each participant is also receiving the 7 other streams plus the main feed. So that becomes a bandwidth constraint at some point on people's networks. But the mixer node that I showed earlier, you could totally take the mixer node and use that to actually mix the streams of all the other participants and then bring that down. And then you can start getting into hundreds or 50, 200, 300 people on the same watch party. I think what you do get into, though, is like really weird user experience problems. Like, how do you even deal with that? Who gets to talk during a watch party of that size? You know, like all kinds of other issues that creep up. But, you know, in terms of just having other people participating, I mean, it could just be showing everybody in an audience kind of mode. I could see that working pretty well with just straight video. But the second you have other people talking, because that's the other thing that's happening in this watch party is like you're actually talking with your friends and like talking about what's happening. And, you know, so getting too many more people in it might get a little funky. So.
Yeah, that makes total sense, and I agree. There is maybe not a logical scaling limit, but there is a practical scaling limit to how big a watch party could reasonably be and still be an enjoyable watch party. That makes total sense. Well, thanks so much for letting us take that aside there, Monica. I'll let you continue. Thank you.
Oh yeah, and that was actually Dave's question was the perfect lead into the next point, which is you can add any variety of additional features. So, you know, this example keeps it pretty simple just for the sake of showing what you can do with a watch party. But Red 5 even has a few other testbed examples that could be worked together with the watch party. So authentication, Chris kind of already mentioned, or Pace mentioned a little bit. But you can also add things like interstitial, which would let you insert media. So if you wanted to put in ads, show stats on the screen, any kind of intermission view, all of those can be easily added. It's fully customizable and really made to be built on. So all of these things are possible. And I think with that, we can move into the demo.
Built
Hey,
to
Monica.
be built on. Is that a tagline you guys have already? If not, you should trademark that. It's pretty good.
One thing I was going to say is this is also on a public GitHub repo now, all the code for this. And we'll share that at the end, I suppose, so that you guys can take a look at it, play around with it. And we'd also love suggestions for other features and how we can improve it and other things. So hopefully we can make it collaborative. We were even talking about how we could turn this into a whole thing and eventually replace StreamYard. So maybe future DO presentations could be using a system like this, so.
Yeah, certainly. Once we've built the basics here in this call with the watch party, we can add on additional features, like they talked about. This is something that is not. It's what it's built for, is to have these additional little features like chat and potentially pay-per-view, things like that.
Yeah. So just really quickly, you can see I'm actually streaming from my phone here, and so you can see the watch party there. And then the latency is pretty good, even though we're doing a screen capture with StreamYard. That's going out over RTMP and then going to whatever you guys are viewing this presentation on. So the round trip time is actually doubled from what it actually is when you're looking at it yourself. And it's difficult to tell that this boxing is actually live. Obviously, this is canned stuff that Mark Pace has running from his OBS, right? From your computer over there.
Yeah, it's just a loop reel of highlights of this fight.
But it kind of gives people the feeling of like, what could you do with it? And like a boxing match would make sense for a watch party, right? And then, but we could switch that out. I don't know if you have access to that OBS device you can just show switching.
You'll give me a moment.
Yeah, and for anyone who isn't clear, the videos down at the bottom here are live, so they are broadcasting that at the same time. Obviously, we're in the call. It would be funny if that was just pre-recorded, but no, these are live watch party broadcasts that they're making in this presentation.
Yeah, so that's what I mean. I can literally show you guys the phone here.
All right, I only have some like cartoon stuff that I can switch us to, but you'll see the transition happening just about now.
Yeah, there you go.
But
so it is technically live coming into this. It's just that OBS, he has just doing these pre-cam videos, but this could be like gameplay, like when people use it from Twitch, it could be live gameplay. It could be a concert, with actual video cameras coming into this, or anything you wanted. We're also doing, we have a partnership with Net Insight, who's a company that makes a product called Nimbra Edge, which allows professional studios to pull their live streams into that, and then we can pull the stream from that content. So OBS is just a simple example, but it doesn't have to be that as the ingest stream. It can be just about anything you want. So we're definitely talking with professional sports groups to do this sort of stuff right now. And this is like, everybody's kind of looking into this stuff at the moment.
Yeah, big business, big part of the developing landscape over the past couple of years. And Gagan asked a question in the chat, which was, can you do simultaneous screen sharing? And I believe for a watch party, we're talking about kind of one person doing a screen share, more or less, or one person doing a broadcast from their local computer. So to answer the question, I would assume the answer is yes, we could add that feature in, but it's not the way it's designed right now.
Yeah, not in this particular example, but yeah, you totally could do that. Some of the things we've been seeing that people want, especially with a kind of watch party use case, would be the ability to like switch which camera view. Like, so we could collectively, let's say let's say it was the Super Bowl that happened this weekend, right? And if you could watch with your friends and let's control what camera we watch together, that would totally be possible. And that's sort of, it's not exactly a screen share, right? But it's another view and allowing people to watch and control it themselves. I think that kind of stuff would be really cool. We're working with an air show group. Mark mentioned something earlier, but they're doing an app that's very much like that, where you can pick which cockpit view you want to see during the live event on your mobile app, and that's kind of this interactive view of what's happening. It's almost a reverse of the watch party, actually. It's I don't know. That's the cool thing about this stuff. There's all kinds of permutations of these concepts, and how do you put them together? And I think that's where the real creativity comes in.
Absolutely, I agree. That's what I'm excited about. So many more people getting into this space, and it becoming so much more accessible with tools like Red 5 that allow people who are experts in other industries, who may have experience in those industries, to come bring their expertise and ideas into the video streaming space. And I think we're going to see some really exciting stuff pop up in the next few years as this continues to develop.
But, to Gagan's point about this, like, can you bring in another screen? Yeah, that would just be another video, and we'd just add another one in here. I mean, it's really subscribing to another video. It's as simple as that. So.
Awesome.
All right.
Do we have any more slides that we wanted to go through?
I don't think so. I think we were keeping it pretty short.
Okay, awesome.
Straight to the point. I would love to get into other questions that people have, any kind of.
Yeah, I did have a question. Obviously we've talked about a few protocols here today. So we talked about WebRTC and RTMP.
Mm-hmm.
This is something you mentioned, StreamYard using WebRTC, and a lot of other streamers are using WebRTC. What is that really the dominant protocol in the space right now, or do you see other protocols that have advantages popping up, or is it really just going to be WebRTC in the future?
Man, it's WebRTC is really good at targeting browsers today and getting the latency as low as possible. That's what it's really good at doing right now. But there are other, we use SRT, which is this other protocol called Secure Reliable Transport. That's kind of more of a broadcast. It's almost the replacement for RTMP now, is kind of what people are looking at. It's a UDP based protocol. It's secure. RTMP by default is not, so you could actually rip the streams in real time. But we actually support a lot of different protocols. We support RTSP, SRT, and MPEG TS, which is kind of the raw format. You can do that over UDP. You can do it over simulcast or unicast. We support a lot of different protocols. HLS is the HTTP live streaming. That's a high latency live stream. So we'll use that for the recordings. So you can also record the live streams that are happening. Like, when you were seeing all of our streams coming in, we can actually easily flip a flag with that publish to the stream, and then it would be recorded on the server. Now, I don't know what you would want to do with like Mark, Monica, and me, like just standing around chatting, like that's not that interesting, but lots of people are doing recordings with this stuff, user generated content, kind of like, Facebook Live style stuff and other things where the recordings are really important. For those, you end up using HLS because you don't care about the latency when it's just video on demand. And then you can integrate with, CDNs for delivery of that. We have a partnership with Fastly where we often will recommend people use a group like that to do the VOD aspects. But anyway, so protocols, we're very practical about this stuff. We try to use whatever makes sense for the situation. Just turns out that WebRTC is probably the best for real-time latency, targeting browsers in particular.
Yeah, that's good to know, and I think that's something that everyone out there appreciates your expert opinion on. So thank you for that. Great. Well, I don't see any other questions in the chat. If anybody has any other questions, okay, perfect timing, Gagan. So Gagan has a question: how do DO load balancers handle hundreds of thousands of open ports for WebRTC for Red 5?
That's a good question. If you go back to my screen share, I can kind of answer this. So in the case of the stream manager is really the only thing that's load balance on DO. So you'll have multiple stream managers running on, multiple droplets, right? And then the load balancer is really only handling the signaling call. So when you're dealing with WebRTC, they have this step called signaling, which is basically how do I pair this peer with another peer so that we can receive video, right? And so what you do for that is you use a secure WebSocket connected to the stream manager. This runs through the load balancer. And then we target over the cloud backend to that node and basically allow these two to communicate with each other. Of course, the stream manager also has that REST API that I mentioned before that you can call, and that's just standard HTTP load balancing. So all of that's basically handled by the load balancer. But what ends up happening is once you get through this signaling layer, the WebSocket technically goes away, and then it does the ICE exchange, it does the encryption over UDP, and then the video starts flowing directly down to that client. So actually, it steps out of the picture, and it's just going from this droplet down to the client. And then this droplet can handle a couple hundred different connections. And this is how we scale out. You just add more and more edges so that more and more people can receive the stream. So it's not actually the load balancer that's having to scale in this case. It's really just the number of droplets in the architecture. And they're all handling their own UDP connections going out. Hopefully that helps answer that question.
Yeah, I thought that was a great answer. Thanks for that, Chris. I hope that does answer your question, Gagan. So with that, we're getting close to the 45-minute mark here, and we don't have any other questions in the chat. If anyone else does have any questions, please feel free to post those in the next minute or two. But I wanted to say thanks so much to everyone from the Red 5 team for making the time today and putting together the presentation. Those diagrams are all really interesting. And I'm sure we'll get questions for or requests for copies of those diagrams from folks on this call. But really appreciate y'all making the time. It's been wonderful talking to you today. I feel like we got a lot of really interesting stuff covered, and I'd love to have a follow-on session where we build on the stuff we've talked about today to add more of those cool features we were talking about to watch party.
Speaking of that, where's the URL for the GitHub repo? Let's put that in the chat.
That's a good point. Yeah, let's make sure everybody has access to that. So we have a GitHub repo that,
and it's like I said, it's super bare bones right now, so don't expect much documentation. But all the code's there, and then we're going to start filling it in. We actually just made it public today so that we could have it. People have access to it today. So. Yeah,
and this is an open source, or it's on GitHub. I believe all of it's open source right now, and anybody can run their own watch party with this. So you can test it out on your own. Get some friends together, watch a football match, and I say that so I'm applicable to the whole world. They don't know what I'm talking about, but absolutely, this is something we'll get you guys that link.
Did you post it, Pace, or one of you?
I put it in the chat. I'm unsure if it's in the private chat or the public one.
It's in the private chat right now. There we go. Great. So we got we got it posted on all the channels here, all the chats, so everyone has access to that,
cool.
Which is wonderful. Please, test that out. You are welcome to make contributions to the repo if you want to make documentation, help out other people who are trying to figure that stuff out. Obviously, this is an open source project, so the whole community is welcome to try and contribute.
All right, awesome. Thanks, guys.
Great talking to y'all. Have a great rest of your day, and I hope everyone who tuned in has a wonderful rest of your day as well.
All right.
Thanks, everyone.
Bye-bye.
Thank you.
Bye-bye.